Welcome back to the Deep Dive. Today we're drilling down on a really specific piece of hardware. It's the NTI ST-1FODVI-R-SC500M.
That's a mouthful.
It is, yeah. It's an optical DVI receiver. And our mission today is to figure out how this thing solves a huge problem taking older standard analog video signals and pushing them across massive distances using fiber optics.
Well, you've hit on it. It's a perfect example of purpose-built engineering. It's really tackling two different challenges at the same time.
Okay.
You have signal conversion and you have extreme distance extension. And the specifics here really matter. You're looking at a price point of around $425 and, this is critical, it's TAA compliant.
And TAA compliance, that's not just a sticker.
Right? Not at all. It's a guarantee. It means the whole supply chain meets really strict U.S. government security standards.
Yeah.
So, this makes it suitable for federal military high security stuff.
Okay, so let's unpack that function. It takes something like S-video or composite video formats you still see everywhere in older industrial cameras.
Yeah.
And it turns them into a modern optical DVI signal.
Right. But there's a catch. The model we're talking about, the ST-1FODVI-R-SC500M, that's just the receiver.
Ah, okay, so it's one half of a system.
Exactly. Its job is pretty simple. Take the light from the fiber and turn it back into an electrical DVI signal for a monitor. The real heavy lifting happens back at the source.
With a transmitter unit.
Yes, a separate converter and transmitter. That's the piece that does the initial analog-optical conversion. And often it'll even have a local analog output so you can, monitor the feed right there at the source.
Now, this is where the technology really starts to shine, I think.
Right.
The distance.
Yeah.
We're talking up to 1,640 feet. That's 500 meters. I mean, that is over a quarter of a mile for a video signal. How is that even possible?
It's just physics, really. You're using light, not electricity.
So no interference.
None. You completely eliminate all the RF interference, the electromagnetic noise that would just destroy a copper signal over that kind of length. And it does this with a single strand, a simplex multimode SC fiber.
Which is more cost-effective.
Much more cost-effective for these kinds of medium to long distances. It keeps everything simpler than, say, a single-mode system.
So that raises the big question. When you prioritize distance like that, what's the trade-off? What are the limitations?
The trade-off is resolution. It's immediately obvious. The max supported resolution here is 12.8 by 1A24.
So definitely not 4K.
No, but it doesn't need to be. It's a perfect match for the kind of robust, lower-res analog feeds it was designed to carry in the first place.
Yeah, and the physical connectors themselves.
Very straightforward. You've got one female SC connector for the fiber coming in, and one male DVI-D single-link connector that just plugs right into the display. Simple.
Okay, so zooming out a bit for anyone thinking about deployment, what are the logistical needs? Power, for instance.
Standard stuff. It's handled by an AC adapter, and it supports global input, so 100 to 240 VAC.
Which again points to its use in big, maybe even international infrastructure.
Precisely. And you see that reinforced with the regulatory approvals. It has CE, FCC, OROHS. Those are non-negotiable in professional settings. They guarantee safety, compatibility, all that. Plus, you get a 2-year warranty, which shows they stand behind its reliability.
So when you put it all together, what this really means for you, the listener, is that this NTI receiver and its transmitter partner have a very specific, very powerful job.
Yep.
They keep vital, reliable, legacy analog gear in service, visible on modern digital screens. And they do it by overcoming the huge physical problems of distance and noise.
Exactly. And that actually brings us to a final sort of provocative thought. When a device is built specifically to extend the life of a system that might be decades old, what does that really tell us?
What do you mean?
Well, what does it say about the strategic importance of just keeping things running? It makes you wonder, are some designers prioritizing the proven reliability of older formats, even at 1280 by 2024, over the, the expensive and maybe unnecessary chase for the highest possible resolution?
It forces you to weigh the cost of a full upgrade against the absolute necessity of just keeping the lights on.
It does. It's a fascinating balance.